Dear students, we finished our 6th module biomolecules. Today let us start a new module, that is the third module about aromatic hydrocarbons. So let us discuss about aromatic hydrocarbons. So what are aromatic compounds? They are the compounds responsible for aromas of certain oils like oil of wintergreen. Aroma, in Greek aroma means odor, fragrant odor. So the aromatic compounds are compounds having certain type of aroma or smell. Then investigative studies into the structures and related properties of aromatic compounds actually began with the discovery of benzene by Michael Faraday in 1825. So more studies into the structures and related properties of aromatic compounds started with the discovery of benzene. Benzene is one of the important aromatic compounds. So chemists realized that the term aromatic was not fully suitable because several such compounds did not have any fragrance at all. So by noting the smell, we cannot confirm whether a compound is aromatic because there are certain compounds which do not exhibit any fragrance, but they are still considered as aromatic. So based on the smell, we cannot confirm whether a compound is aromatic or not. The term is still being used but with a different meaning to signify compounds having a certain kind of structure. So based on the structure, aromatic compounds have a common structure. So based on the structure, we can classify them as aromatic compounds, not based on their aroma or smell. Next we can see nomenclature of benzene derivatives. That means how we can name benzene derivatives. The benzene C6H6 may be written as in this way. Benzene contains 6 carbon atoms and on each carbon there is one hydrogen atom attached to it. Then there are 3 double bonds and there are 3 single bonds. They are alternatively arranged in this way. So one of the way to represent benzene is this. Then we can alternate the double bond and single bond. Here in this structure, this C double bond C is here, and in this structure, this is the the C double bond C is there. Here C double bond C is here. C single bond C is here, but in this structure, C double bond C is here. So we can alternatively write this structure, alternatively represent this structure in this way and in this way. There are 2 structures for this structure. Then we can represent benzene without carbon and hydrogen in this way. This structure means on each carbon or each corner represents a carbon and on each carbon there is a hydrogen. Then benzene can also represent in this way with a ring inside the carbon, ring inside the hexagon. This is the hexagonal ring with alternative single bond and double bond. We can alternatively represent this structure with this structure in this way. That means here in this structure there is double bond here, but in this structure the double bond is not here, only single bond. So alternatively we can change the single bond and double bond and we can get 2 structures for for benzene. Then without alternate single bond and double bond, we can represent the benzene with a ring inside the hexagon. The ring inside the hexagon indicates system of delocalized pi electrons. Benzene contains 3 pi bonds and 3 single bonds. Not 3, 6 single bonds. Here 1, 2, 3, 4, 5, 6 and 3 pi bonds or double bonds. So generally we can represent with 3 structures. One is this, then alternative form of this is this one. Then another structure is without carbon hydrogen representation. Then that means without showing carbon and hydrogen atoms like this, we can represent benzene in this way. Then alternative form of this one is this structure by changing the carbon single bond and double bond. Then third one is by representing with a ring inside the hexagon. These are the three ways of representing benzene rings. Now for naming we can use this phenyl group. This is the phenyl group, that is a C6H5 group. Then C6H5CH2 group is known as benzyl group. So we can use these two groups for naming the benzene compounds. Now let us see the nomenclature of substituted benzenes. First, let us discuss about the naming of monosubstituted benzenes. When a single hydrogen of benzene ring is replaced by a group, we get a monosubstituted benzene. So, in the case of chlorobenzene, from the benzene, a hydrogen is replaced by a chlorine atom, we will get chlorobenzene. So, this one is a monosubstitute. Mono means one. This contains only one substituent, so this is a monosubstituted benzene. A compound is named as a derivative of benzene by giving an indication about the substituent as a prefix to the word benzene. So, in the case of a naming of a compound, derivative of a benzene, usually the substituent is considered as the prefix, and the prefix word should be added to the word benzene. That means if we have to name a derivative of a benzene, the substituent is considered as a prefix. The name of the substituent is considered as a prefix, and it should be added before the word benzene. So this is chlorobenzene. Here substituent is chloro group. So chlorobenzene. Substituent should be added before the word benzene. Then bromobenzene. Bromo word should be added before the word benzene. Then nitrobenzene. Nitro is the prefix group. Then ethyl benzene. Ethyl is the prefix word. Then isopropyl benzene, or we can say this is cumene. This is the isopropyl group, also secondary alkyl group. Secondary means a carbon which is attached to other carbon. So this is isopropyl group. Isopropyl is the prefix word for the substituent. Isopropyl benzene is this compound that is also known as cumene. Then secondary butyl benzene. This is secondary butyl benzene. This is butyl group, but at the same time it is secondary. Secondary means the carbon is attached to two other carbon atom. In this case, alkyl group. In the case of alkyl group, the carbon is attached to two other carbon atom. So this is secondary butyl group. But in this case, this is tertiary butyl group. In this case, the alkyl group is tertiary alkyl because the carbon is attached to three other alkyl group. This alkyl group is tertiary alkyl group, whereas this alkyl group is secondary. So this is tertiary alkyl benzene, this is secondary butyl benzene. We are considering only the attachment within the alkyl group. We are not considering this attachment. So this carbon is secondary, this carbon is tertiary. Some monosubstituted benzenes have common names without the necessity for specifying the substituents, which are accepted by the IUPAC. IUPAC means it is an organization for naming compounds, International Union of Pure and Applied Chemistry, and are used preferentially over other possibilities. That means in some cases we are not mentioning the prefix word substituent. That means in this case the substituent is methyl. We are not naming it as methyl benzene, but usually we use its common name. Its common name is toluene. There are some compounds whose common names are accepted by IUPAC. So we can use the common name. So we are using the common names, not the derivative of benzene. like methyl benzene, hydroxybenzene. Usually we use the common names. So in this case, this is toluene. The substituent is methyl group. Then here the hydroxyl group is the substituent. We are using it as, we are naming it as phenol. Then this is aniline, benzaldehyde, benzoic acid, anisole. If the substituent is OCH3, then it is anisole. Then styrene and benzonitrile, benzene sulfonic acid, benzene diazonium chloride. So these are the common names of some common compounds. We are not using the, we are not naming them as with the substituent attached benzene, like methyl benzene, hydroxybenzene, etc. Only we are using the common names like toluene and phenol. Now let us discuss the benzene ring with complex group. When the substituent on the benzene ring is a complex group which cannot be easily named, then the C6H5, that is a phenyl group, can be treated as the substituent and the compound named as in the case of an aliphatic compound. The C6H5CH2 benzyl group can also be treated in the same manner. That means when the substituent is a large or complex group, we can name the compound by using the phenyl group as a substituent. So in this case, this is the parent compound and this is the phenyl group is a substituent. So 2-phenyl hexane. On the second carbon there is a phenyl group. So 2-phenyl hexane. This is diphenyl ether. On this phenyl group there is this large group. So this can be named as a diphenyl ether. This part is benzyl group. So dibenzyl ether. Actually on this phenyl group there is large substituent. So we can use the phenyl or benzyl group as the substituent and the other group is a parent part. So this is dibenzyl ether. Simply two groups are same, so dibenzyl ether. Here also the two groups are similar, so diphenyl ether. So if there is a large substituent, we can consider the phenyl or benzyl group as the substituent. The other part is considered as the parent compound. Then what about the naming of disubstituted benzenes? It gives rise to position isomerism. That means disubstituted benzenes gives position isomerism or position isomers. Substitution of two hydrogen atoms of benzene by two similar or dissimilar groups gives rise to the possibility of position isomerism. Three isomeric disubstitution products are possible which are position isomers. So from benzene, when two hydrogen atoms are replaced by two substituents which may be similar or dissimilar, then that will give rise to position isomers, and the isomerism is known as position isomerism. So either the prefixes ortho, meta and para or numbers are used to indicate their relative positions while naming the three isomers possible. So here we have one benzene with two chlorine atoms attached on the benzene. So this is two chlorine atoms are attached on 1 and 2 carbon atoms. So we can name it as 1,2-dichlorobenzene or ortho. When the substituents are on the first and second position, they are named it as orthoisomers. Ortho-dichlorobenzene or O-dichlorobenzene. Ortho-dichlorobenzene or abbreviation for ortho O. O-dichlorobenzene, then also 1,2-dichlorobenzene. So then if the substituents are on the 1 and 3rd position, then it can name it as 1,3-dichlorobenzene, then meta-dichlorobenzene or M-dichlorobenzene. Then if the substituents are on the 1 and 4th, then they are named as 1,4-dichlorobenzene, then also para-dichlorobenzene or P. Para-dichlorobenzene or P-dichlorobenzene. So based on the position of the two substituents, there are three different isomers, ortho, meta and para. If the substituents are on the 1 and 2 position, it is ortho isomer or O isomer, or we can name it as 1,2 dichlorobenzene. In this case, 1,2 dichlorobenzene. Then if the substituents are on 1 and 3rd position, 1 and 3 position, then it is meta dichlorobenzene or M dichlorobenzene or 1 and 1,3 dichlorobenzene. So this is meta isomer. If the substituents are on 1 and 4th position, then if the substituents are on the 1st and 4th position, then it is para dichlorobenzene or para isomer. So three isomers, ortho, meta and para, based on the positions of substituents. If the two substituents are different, they are considered in the alphabetical order, and the first in the order is assigned the first position on the ring. That means in the case of dichlorobenzene, two substituents were same. But if the substituents are different, two substituents are different, we have to consider the substituents in the alphabetical order. So the substituent which comes first in the alphabetical order should give the first position. That means in this case there are two substituents, nitro group and chloro group. So in the naming chloro, that means the letter C comes in the naming, the first letter is C, but in the case of nitro group, first letter is N. So which should come first in the alphabetical order? The chloro group comes first. That means C letter is first in the alphabet, then only the letter N comes. So which substituent comes first in the alphabetical order, that should give the first position. So chloro group should give the first position. Then 1, 2. Don't name like this 1, 2, 3, 4, 5, 6, because then if we give the first substituent position 1, then the next substituent should give the lowest number position. That means if we number in this way, it will be 6th position. But if we number in this way, it will get the 2nd position. So the second substituent always should get the lowest number. The numbering of the other carbons in the ring is considered in that direction in which the second substituent gets the lowest number possible. So first number is based on the alphabetical order of two substituents, and the second numbering is based on the lowest number possibility of the second substituent. So here it is the ortho isomer, because substituents are on the 1 and 2 positions. So ortho chloro nitrobenzene. In this case, bromo group and iodo groups are there. So bromo group come first in the alphabetical order because B letter comes first, then I. So 1 bromo, 3 iodo, not you have to name in this 1, 2, 3, not 1, 2, 3, 4, 5. If we name in this way, the iodo group will get a 5th position. So always remember that the next substituent should get a lowest number. So 1 bromo, 3 iodobenzene or metabromo iodobenzene. In this case, 1 chloro, 4 ethyl benzene. Chloro group comes first in the alphabetical order, and the naming is 1, 2, 3, 4. In this way also the naming is same, 1, 2, 3, 4. 1 chloro, 4 ethyl benzene, that is para-chloroethyl benzene. So this is naming about disubstituted benzenes. The substituent, in this case the substituents are different. However, if the name of one of the substituents is already incorporated into the name of the compound, then the incorporated substituent is given the first position and the number 2, 3 or 4 or the specification ortho, meta or para assigned to the second substituent on the basis of its position relative to that of the first on the ring. That means in this compound 4-bromo-aniline, para-bromo-aniline, or 4-bromo-aniline also known as para-bromo-aniline. That means in this compound the compound without bromine group is known as aniline. So one of the substituent is incorporated into that name. So this part is aniline without bromine group. So the incorporated substituent should give the first position. So this is 1, 2, 3, 4. So this is 4-bromo-aniline. Only you have to focus on the substituent position of the other substituent. The other substituent is incorporated into the name of that compound. So 4-bromo-aniline, and in this compound the compound without nitro group is phenol. So the OH group should give the first position. Then 1, 2, 3. This is 3-nitrophenol or metanitrophenol. This one is 2-chlorobenzoic acid. The compound without chlorine group is benzoic acid. That is the common name of compound with common name of a benzene ring with COH group. So the other substituent is chlorine group, that is on the second position. So 2-chlorobenzoic acid or orthochlorobenzoic acid. In some cases, two substituents are incorporated into the name of the compound. That means there are a few disubstituted benzenes which have the names that incorporate both the substituents. So in this case, the compound is named based on only one substituent, that is aniline. But in this case, the naming is given based on the two substituents. In this case, the serine contains 2 methyl group. Because of the presence of 2 methyl group, this compound is known as serine. If there is only one CH3 group, it is toluene. So the compound itself is named based on the two substituents, that is silane. Then if there is another substituent, then we have to give the position of that substituent only. Then this is metacresol. If there is a benzene ring with OH group and CH3, that is known as metacresol. Then if there is a third substituent, you should give the position of that substituent only. Then this is toluene. That means the compound contains CH3 group and NH2 group. So they are in the ortho position, so orthotoluene. So this is the naming of disubstituted benzenes. Then what about the naming of polysubstituted benzenes? When more than two groups are attached to a benzene ring, their positions are indicated by numbering the carbon atoms of the ring such that first priority is given to assign the lowest numbers to the attached positions. That means when more than two groups are present on the benzene ring, first priority is for assigning the lowest numbers to the attached position. That means the substituents are then indicated in the alphabetical order. That means when we name a compound with more than two substituents, first priority is giving the lowest number to the attached position. In this case 1, 2, 3, 4. You cannot name this compound in this way 1, 2, 3, 4, 5, 6. So the substituents will get highest attached positions. In this way we can name this compound 1, 2, 3, 4. Then the positions are 1, 2 and 4. But if we name this compound 1, 2, 3, 4, 5, 6, then substituents will get 1, 4 and 6 positions. So lowest summer rule will not be possible in this case. sorry, 1, 4 and 6. Yes, 1, 4 and 6 is equal to 5, 11. Then but in this case 1 plus 2 plus 4, 3 plus 3 plus 4, 7. 7 is the sum. So always remember that the substituents should get lowest positions, and also should consider their alphabetical order. So here 2-chloro, in the naming the substituents should name in the alphabetical order. 2-chloro, 4-ethyl, 1-nitrobenzene. You cannot name from this carbon 1, 2, 3, 4, 5, 6. Then also the sum will be very high. If we name from this carbon also, the name sum will be very high. 1, 2, 3, 4. The substituents position will be 3, 4 and 1. So always this numbering is correct. 1, 2, 3, 4. The positions will be 1, 2 and 4. So in this case, consider this case, why we name from this carbon. Always consider the substituents should get lowest position. If we name from this carbon 1, 2, 3, 4. So the substituents will get 1, 3 and 4 positions. So sum will be very high. Then if we number from this way 1, 2, 3 and 4, then the number will be 1, 4, 2 and 4. Sum will be low. I think you have learned the lowest sum rule in your plus 2 classes. Then if we name from this carbon, consider this carbon as a first carbon 1, 2, 3, 4, 5. Then also the sum will be very high. That means position of the substituents, the number that means the attached position should get lowest number in the naming. This is the possible way. In this case, the numbering is the positions should get in this way. When we number the compound, the attached substituents should get is getting lowest number. That means 1, 2, 3, 4. So the naming is 4-bromo, 1-chloro, 2-iodobutane. In the naming, always remember that you have to follow the alphabetical order. Bromo first, then 1-chloro, then iodo. B, C, I. Then in this case, you have to number in this way only. 1, 2, 3, 4. If we name in this way 1, 2, 3, 4, 5, 6, then the position number of the substituents will be 1, 4 and 6. So sum will be very high. If we name in this way 1, 2, 3, 4, then substituents number will be 1, 3 and 4. Then in that case also the sum will be very high. So you have to consider the alphabetical order, and also at the same time you have to give the substituents position with lowest number. That is the rule for polysubstituted benzenes. So try and then finally try one time with all the substituents and write the sum. Then try another way, then write the sum. Then in all the way, if you get the lowest sum, then that is the possible way for naming the compound. Then if one of the substituents is already incorporated into a name, that substituent is given the first position, and the numbering of the carbon atoms is then done in such a manner that the lowest possible numbers appear in the name. That means in this case that the CH3 substituent is incorporated into the name of the compound. That means toluene. This is considered as a derivative of toluene. So the substituent which is incorporated into name of the compound is considered as is giving first position. So this is first position, carbon number 1, then 2, 3, 4. then all other substituents should get the lowest possible number. That means if we name this compound in this way, that means 1, 2, 3 and 4, the 4, 5, 6, then the substituents will get high numbers. That means this is the only way to name this compound, 2-chloro-4-nitrotoluene. In this case, this is a derivative of phenol. So, only possible way for naming this compound in order to get the lowest possible numbers for other substituents, this is the way, 4-bromo, 2-chlorophenol. This is a derivative of aniline. So, the possible way for naming the other substituents only in this way. If we name this compound in this way, 1, 2, 3, 4, 5, 6, then the substituents will get 1, 6 and 4 position. Then sum will be very high. So always the incorporated substituent should give the first number, then other substituents should get the lowest possible number. So 2-chloro-4-nitro-aniline. These are about the namings of the polysubstituted aromatic compounds. Thank you.